Namaste. This is Dr. Vishal Saxena, Associate Professor in Jayoti Vidyapeeth, Women's University, Jaipur. Today I am going to discuss about the module Measure of Dispersion. As the name suggests, the measure of dispersion shows the scatterings of the data. It tells the variation of the data from one another and gives a clear idea about the distribution of the data. The measure of dispersion shows the homogeneity or the heterogeneity of the distribution of the observations. Suppose we have four data sets of the same size and the mean is always same. Suppose M, in all the cases the sum of the observations will be the same. Here the measure of central tendency is not giving a clear and a complete idea about the distribution for the four given sets. The main idea about the measure of dispersion is to get to know how the data are spread. It shows how much the data vary from their average value. So this is a part of the definition of measure of dispersion, and mainly we can say will give the it will give the nature and the spread of the data set, and which is unable to explain by the measure of central tendency. Next, we take the characteristics of measure of dispersion. A measure of dispersion should be rigidly defined. It must be easy to calculate and understand, not affected much by the fluctuations of observations, and based on all observations. So these are the four important characteristics of measure of dispersion. Uh, like first, a measure of dispersion should be rigidly defined, and second is it must be easily to calculate and understand. Third is not affected much by the fluctuations of observations, and fourth point of the characteristics is based on all observations. So next, we take the classification of measures of dispersion. Classification of measures of dispersion. The measure of dispersion is categorized as first point an absolute measure of dispersion, and second point is a relative measure of dispersion. In the first part, an absolute measure of dispersion, the measures which express the scattering of observation in terms of distances, that is range and the quartile deviation. And the second point is the measure which expresses the variations in terms of the average of the deviations of observations, like mean deviation and standard deviation, standard deviation. And the second category of classification is a relative measure of dispersion. We use a relative measure of dispersion for comparing distributions of two or more data sets, and for unit-free comparison. They are the coefficient of range, the coefficient of mean deviation, the coefficient of quartile deviation, and the coefficient of variation, and the coefficient of standard deviation. So now we discuss about the four components of the measure of dispersion. And the first component is known as range. The second component is known as quartile deviation. Third component is called the mean deviation, and the fourth component is the standard deviation. So first we take the first component of measure of dispersion, that is range. A range is the most common and easily understandable measure of dispersion, and it is the difference between two extreme observations of the data set If x maximum and x minimum are the two extreme observations, then range is given by x maximum minus x minimum. So range is given by x maximum minus x minimum means the largest value minus the smallest value of the given data set. And one more definition we can use here for the coefficient of range. Coefficient of range is given by x maximum minus x minimum upon x maximum plus x minimum. So this is the part of the range, and we have some merits and demerits of range. So first we discuss about the merits of range, how it is useful. It is the simplest of the measure of dispersion. It is too easy to calculate and easy to understand and independent of change of origin. So these are the four merits of the range. In other words, we can say it is very easy to calculate and quite easy to understandable form, independent of change of origin, and it's a very simplest of the measure of dispersion. Now next we discuss about the demerits of range. It is based on two extreme observations, hence get affected by the fluctuations because just we are using only two extreme observations and therefore it will be affected by the fluctuations. A range is not a reliable measure of dispersion because it depends only the two extreme values of the data set. One is called the extreme value, one is called the maximum value, and second is called the minimum value. And the third point of the demerits is the dependent on change of scale. So when we change the scale, then it will be range will be affected by this, and it is a negative point or it is a demerit or drawback of the range. Now next, we discuss about the second component of measure of dispersion, which is known as quartile deviation. The quartiles divide a data set into quarters. The first quartile, which is known as Q1, is the middle number between the smallest number and the median of the data. The second quartile, which is known as Q2, is the median of the data set. And the third quartile, Q3, is the middle number between the median and the largest number. So in this way, we have defined the three quartiles. Q1, which is the middle number between the smallest and the median of the data set. And the second quartile, Q2, is called the median. And the third quartile, Q3, is the mid number of median and the largest number. Now next, we take the formula for the quartile deviation, or also known as semi-interquartile deviation. So the formula for the quartile deviation is given by Q is equal to 1 upon 2 into Q3 minus Q1, half into Q3 minus Q1. And next, we take the merits and demerits of the quartile deviation. So merits of the quartile deviation are given by first point, all the drawbacks of range are overcome by quartile deviation. So it is very important point that the range has some drawbacks, but these are overcome by quartile deviation. Second point is it uses half of the data. So only half of the data are used by the quartile deviation and independent of the change of origin. So when we change our origin, so the quartile deviation will not be affected by this. And one more point of merit of quartile deviation and can be given as the best measure of dispersion for open-end classification. So it is best measure of dispersion in the case of the open-end classification. Like similar to merits, again quartile division also has some demerits. So first point of demerit is it ignores 50% of the data. So because we are using only 50% of the data and 50% of the data are ignored, therefore it is again not a reliable measure of dispersion and dependent on the change of scale. So when we change our scale, the quartile division will be affected by this. So again, it is a drawback for this quartile division that it will depend upon change of scale, and it is not a reliable measure of dispersion because we are using only 50% of the data and the remaining 50% of data are ignored. Next is the mean deviation. The mean deviation is the arithmetic mean of the absolute deviations or the observations from a measure of central tendency. If x1, x2, x3 and till xn are the set of observations, then the mean deviation of x about the average value, and a means average, maybe mean, median or mode, or maybe other average value. So this mean deviation can be defined as it is equal to 1 upon n and multiply by summation of xi minus a. Small n represents the total number of data in the given data set. Xi represents the respective data with I in suffix, and a is the average value and by which the mean deviation is to be calculated. And a may be mean, median or mode. For a group frequency, it can be calculated as mean deviation from the average A is given by 1 upon n summation of fi into modulus xi minus a. Just there is a difference between the two about two formulas here, that the in the group frequency the term of frequency will come there, and in the individual case it is not present there. So the formula is given by 1 upon n, capital N, and n represents the total number of data. That means summation of fi into summation fi into xi minus a. Fi represents the frequency, xi represents the data, and a represents the average value by which the mean deviation is to be calculated. So next we are taking the merit and demerit parts of the mean deviation. So we are discussing the 3 points of merit for the mean deviation. The points are based on all observations. So mean deviation depends on all observations, and it provides a minimum value when the deviations are taken from the median. So the very important point this one is that it will give not easily understandable. So mean deviation is not very easy to understand. So it is a drawback because there is a complex formula is there, and its calculation is not easy and time consuming. So when we solve by the formula, so calculation will be not easy and it will take some time to calculate. So again, it's a drawback in the case of the mean deviation to calculate it, and dependent on the change of scale. So again, this is a drawback of the mean deviation, because when we change our scale, then mean deviation will be affected by this. And ignorance of negative signs creates artificially and becomes a useless for the further mathematical treatment. Because in the formula we have used the absolute value sign there, and therefore just it will give the positive values and the negative values will be not included there, and therefore it is not very useful for the further mathematical calculations or mathematical concepts. So again, this is a drawback of the mean deviation. Next, we will discuss about the standard deviation. The standard deviation is the fourth component of the measure of dispersion. A standard deviation is a positive square root of the arithmetic mean of the squares of the deviations of the given values from the arithmetic mean. It is denoted by a Greek letter sigma, and is also referred to as root mean square deviation. The standard deviation is given as sigma is equal to summation yi minus y bar whole square upon n, and the whole term is written in square root. So yi is the data we have, and y bar is its average value, mean value, while small n choose the total number of data. And when we solve this formula further, so it can be reduced to another formula, and this will be useful for the calculation part. So this is given by summation of yi square upon n minus y bar square, and the whole term is written in the square root. And for a group frequency distribution, this formula can be written as sigma is equal to summation fi into yi minus y bar whole square upon n, and which is also equal to summation fi yi square upon n minus y bar square, and then the whole term is written in the square root. So in this way, this is the formula. These are the formulas to calculate the standard deviation for the individual series, and for the group frequency distribution means where the frequency will come in the distribution. So the square, next we define the part of the variance. The square of the standard deviation is called variance. Means if sigma represents the standard deviation, then sigma square will be known as variance, and it is also a measure of dispersion. So sigma square is equal to summation of yi minus y bar whole square divided by n, and yi represents the data, where and y bar shows the average value or the mean value of data set, and n represents the total number of data. And it can be also written as a summation of yi square upon n minus y bar square. And this formula for the variance in the case of the group frequency distribution can be given as sigma square is equal to summation of fi into yi minus y bar whole square upon capital N, and this is equal to summation fi xi square upon n minus x bar whole square. So in this way, just if you calculate sigma, that means standard deviation. So variance is just given by the square of the standard deviation, and we have seen these formulas. We can use these formulas to calculate values for the data set. If instead of a mean we choose any other arbitrary number, say a, the standard deviation becomes the root mean deviation. Means if we replace y bar by the other average value a, then it is called the root mean deviation. Now next we discuss about the variance of for the combined series. So if sigma 1 and sigma 2 are the two standard deviations of the two series of size n1 and n2, which means y1 bar and y2 bar, then the variance of two series with size n1 plus n2 is given by sigma square is equal to 1 by n1 plus n2, and the whole term is multiplied by n1 into sigma 1 square plus d1 square plus n2 into sigma 2 square plus d2 square. So this formula gives the variance for the combined series and combined series with the standard deviation sigma 1 and sigma 2 and the size of n1 and n2, where d1 is equal to y1 bar minus y bar and d2 is equal to y2 bar minus y bar, and y bar is equal to n1 y1 bar plus n2 y2 bar upon n1 plus n2. Now next we discuss about the merits and the demerits of the standard deviation. So first we take the part of the merits for the standard deviation. Squaring the deviations overcomes the drawback of ignoring signs in mean deviation, and it is suitable for further mathematical treatment because we are taking the squaring terms here. Squaring the deviations overcomes the drawbacks of ignoring sign in mean deviation, and therefore it is suitable for mathematical treatment. Least affected by the fluctuation of the observations, and the standard deviation is 0 if all the observations are constant. So if we take observations or the data is constant values, then the standard deviation will become 0. And the standard deviation is independent of change of origin. Now next we take the part of the demerits of standard deviations, and that these demerits are not easy to calculate. Again, because the complexity of the formula, we can the calculation of standard deviation is not very easy, difficult to understand for a layman, for an ordinary person, and dependent on the change of scale. So again, we can see there it is dependent on the change of scale. So these are the demerits of the standard deviations. Next, we take the part of the coefficient of dispersion. Whenever we want to compare the variability of the two series which differ widely in their averages, also when the unit of measurement is different, we need to calculate the coefficients of dispersion along with the measure of dispersion. The coefficient of dispersion based on different measures of dispersion are: first, based on the range. The coefficient of dispersion is given by simply x maximum minus x minimum upon x maximum plus x minimum. That is the largest value minus lowest value upon largest value plus lowest value. And the coefficient of dispersion based on the quartile deviation. So this coefficient of dispersion in the case of quartile deviation is given by Q3 minus Q1 upon Q3 plus Q1, where Q1 and Q3 are the quartiles, and based on the mean deviation. So when we want to define the coefficient of dispersion in the case of the mean deviation, in the terms of mean deviation, then it can be defined as mean deviation upon average from which it is calculated. And for the standard deviation, it is equal to standard deviation upon mean. Standard deviation upon mean. So these are the definitions of the coefficient of dispersion. Next, we discuss about the coefficient of variation. 100 times the coefficient of the dispersion based on standard deviation is the coefficient of variation. So means just when we multiply coefficient of dispersion with 100 and the coefficient of dispersion is taken is based on the standard deviation, then this is given, this is called coefficient of variation, and therefore coefficient of variation is equal to 100 multiplied by SD standard deviation upon mean. So this is equal to sigma upon y bar multiplied by 100. Now next we take example for the to understand here mean and variance and standard deviation. So the question is calculate the mean and the variance and standard deviation for the following data. So in this question we are given that a table with class interval 0 to 10, 10 to 20, 20 to 30, 30 to 40 and 40 to 50, 50 to 60 and with respective frequencies 27, 10, 7, 5, 4 and 2. So now we are required to find mean, variance and the standard deviation for this table, for this data. So one by one, just we have to calculate all these terms and for which we are required to make a table. So first we are going to make a table and we are taking class interval in the first column. The values of class interval are given. And in the second column, we take the frequencies like 27, 10, 7, 5, 4, and 2. So these are the frequencies in the second column. In the third column, we take the mid values. So mid values of the data that is xi. So 5, 15, 25, 35, 45, and 55. So these are the mid values of the data and taken from the class interval. Just these are taken as the mid value. That is the lower limit plus upper limit upon 2. Like 0 plus 10 upon 2 will give 5. 10 plus 20 upon 2 will give 15. 20 plus 30 will be 50. 50 upon 2 will give 25 and then so on. So in this way the mid values have been calculated. And next we are taking the term of fi. So just we are required to multiply the column of fi with the column of xi. So just we are required to calculate this and we will get the values as 135, 150, 175, 175, 180 and 110. So in this way we have taken these values and next column is made for the term fi square. fi square. So this will be 675 and 2250 and 4375, 6125, 8100 and 6050. So in this way a table is formed and now we calculate the terms like summation of fi. So we have to take addition for all the frequencies and this will come as 55. So the total frequency will come 55 and next we will take the summation of fi xi and it will come 925. The value of summation of fi xi square and this is given by 2000 it is 27,575. So summation fi xi square will be given by 27,575. So now we have the values n means the total number of data and this is equal to summation f. Summation f is equal to 55 and the mean value which is the mean can be determined by the formula summation fi xi upon summation fi, or we can say summation fi xi upon capital N. So this will be equal to 925 upon 55 and after further calculation we can see we can get this value as 16.818. So 16.818 will be the mean, and the variance is given by 1 upon n minus 1, then multiplied by summation fi xi square minus 1 upon n summation fi xi square, and this will be equal to 1 upon 55 minus 1 and multiply by summation fi xi square, so which is equal to 27,575 minus 1 upon 55 and multiply by fi xi square and fi xi whole square, so this is 925 whole square. So when we calculate these values, so finally we will get the value of variance as 222.559. So the value of variance is given by 222.559, and all we look at here about this standard deviation. So standard deviation is the square root of variance. So that is square root of 222.559, and finally which is equal to 14.918. So 14.918 is the value of standard deviation. So in this way we have calculated the values of mean and the variance and the standard deviations in this question. And this is a question from the group frequency distribution, and in the similar way we can calculate the part of the variance or the standard deviation for the other type of problems, the questions from the individual series and questions from our group data. So with this I conclude today's lecture. Thank you.